5, page 5. So, I'm going to look at the standards at the top. I can identify, evaluate cube roots and perfect cubes. I understand the concept of cube roots, and I understand that cubing a number is taking the cube root, are those to our inverses. So we talked about our squares were inverses, right? We are also going to be having cube roots, and taking the cube, those will also be inverse operations, right? So as I begin, as I'm looking at this one, it says find the volume of each one. 5 times 5 times 5. 5 times 5 is 25. 25 times 5 happens to be 125. So you're going to put the volume equals 125 cubic inches. When I look at that next one, the numbers aren't quite as nice. 8 times 8, we know, is 64. And if I take 64 times 8, anyone knows 64 times 8? 64, we're taking it times 8. That's what that meant, right? So 8 times 8 times 8. We are looking at, this is one that you will be working on, memorizing, 512. Now, I am going to be talking about today that I have some flashcards for you that are of your squares and cubes. I talked a little bit on Friday last week about how you can go to the WebPit or how you can go to Quizlet. But we're going to be talking about this list today of how cubing a number and finding the cube root. So as I take a look up here, I'm going to be taking a look at the side length and volumes. It says to find the volume, so you're in that next page down in your notes, to find the volume of a cube, you multiply the 3 sides together. Since they're the same length, and because it's a cube, we usually say that you cube the side length, raise it to the 3rd power. So when we were taking a look at our problems the other day, 6 to the 3rd, that's our exponent called the index, that's our base, and this whole thing represents the power. So 6 times 6 times 6, so if we are looking at these next ones, it says, oh, here's your volume. What is our side length? So I want to be thinking what number times itself. 3 times gives me 27. I am doing this. I am taking the cube root of 27 is going to be equal to the side, which our side then should be, anyone remember it or know it? Yep, go for it. Should be 3. And if you're not sure, you can check, right? 3 times 3 is equal to 9. 9 times 3 equals 27. 343. Not one we might recognize as much, right? 343. But it ends in a 3. And so all of a sudden we kind of start thinking about numbers that could end in a 3 when we are looking at those. And if we put this, and we will be using our calculators at times, and this is bigger than 5, right? Because we saw 5 was 125. And this one, again, we are thinking, take the cube root of 343. We're looking at what number times itself 3 times is equal to 343. And that number actually happens to be 7. And so in this case, we're going to say 7 inches. Now, at this point, did you need to have that memorized or know that? No, not at all, okay? But if we look at this, this is trying to tell us that 7 to the 3rd power is equal to that 343. And this is what we're going to be working on. So on the top of the next page, I have that list for you. It says you need to memorize these. So this is when I was talking about those flashcards. And I have a set of flashcards that we've used the last few years. And some people like them and some people don't. So I'm not going to hand them out to everyone. But if you think these would be helpful for you, check with me. Because I have a bunch of them made up already. And you don't have to remake them. And what it does is on one side it has 1 cubed, and on the back it has 1. 2 cubed, 8. 3 cubed, 27. 4 cubed, 64. If you like to make up your own, or you just like covering up this side of the list so that you can see this and trying to write them, that's what you have to do. So sometimes what I think is that when you have to say things all the time but not write it, you want to be practicing writing them. And you kind of want to practice writing them randomly. Like you want to try and go, oh, 4 thirds is 64, 8 to the third is 5, 12. 10 to the cubed is 1,000. So if we look at this one, it says to cube a number, you multiply it by itself 3 times. 3 cubed is 27. So if we are looking at what is a perfect cube, if I wanted to answer that question, what is a perfect cube? A perfect cube, this is what I would like you to write down, please, in that box that you're looking at. And I'm going to show you their writing because it's a little neater than mine that we have in our notes. A perfect cube, again, no fractions or decimal. Please write this now. A perfect cube is what you get when you cube any integer. Some of you aren't writing, so I would think your pencil, if we get this writing in that box that's right where it says, what is a perfect cube? And the key thing here is that these are our volumes of all the cubes. These are the volumes of our cube. We're going to be talking about classifying of numbers in this unit also, as we look with our rational and irrational. And so this phrase right here that we are looking at, that these are volumes of whole number side lengths, whole numbers, that's like 0, 1, 2, 3, 4, 5, 6, 7, 10. So then that vocabulary on the page down, and a couple of you are still writing, so I'm going to let you write those. But this is what we're going to be working on memorizing. So I will even have you talking to each other and saying, what is, opening your 2 pages to the notes and asking someone, oh, what is 1 squared? And they'd say 1. And then you'd say, what is 5 squared? 25. What is 7 squared? 49. Square root of 49, 7. So we're gonna do some of that in class also so that you can practice. The vocabulary at the bottom of this page says, if you know the volume of a cube, you can work backwards to find the length of one side. Concept is the cube root. In other words, taking a perfect cube and asking what number the numbers were cubed to get that number. The cube root of a number is a special value. When cubed, it gives us the original. Cubing takes the cube root. So cubing and taking the cube root are inverses, are the words we are looking at. So again, similar to what we did the other day, if I take 3 to the third power, so when I take 3 and I take it to the third power, that's how I get 27. And when I take 27, and this time notice I don't put any, I write the number up here as 3, that's taking the cube root of 27, and that gives me this 3. So volume is equal to s cubed. S is equal to the cube root of the volume. Next year when you get into algebra, you'll take other roots than this. You might have some with fractions and some other ones, but at this point we're going to keep these all as whole numbers. So it says here's a list of your cube roots and perfect cubes that we are going to memorize. So again, you need to be able to go frontwards and backwards. Part of our test, when we take this test in about a little over a week or so, maybe a week and a half, okay, 2 weeks, is that I will give you the cube root of 1 and ask you what that is. I'll give you the cube root of 216 and ask you to just fill in the blank. It'll be a 2-point question, okay? And I'll say, well, what is 6 to the third? You'll have to tell me 216. What is 8 to the third? 512. You'll do that with the cubes and the squares when we are taking a look at those, okay? So just so you're aware, that's kind of where we're going with this. So negative numbers. You can also cube a negative number. You have to look at this. So when we think of 5 cubed, we get a positive 125. Positive 5 times positive 5, positive 5. When you multiply two negatives, we talked about this last week, that is going to be positive. When you take a positive times a negative, that is how we get, anytime you take a positive times a negative, that final answer is going to end up being negative. So we get a negative 125. So if I ask this question, the cube root of 64, that is just going to be 4, but if I put this negative out in front, it's telling me negative 2. This is called the index. If there is nothing written there, and I have this, and I have the square root of 4, it is understood. We don't write it. Mathematicians like to take shortcuts. Some of you might also. It's understood that there's a 2 there. We usually don't write that 2 in. It's just people always know that if I'm taking the square root of 4, that means what times itself twice. Someone said, well, what if I put this in? Are you going to mark it wrong? I wouldn't. But really, we want to try and get used to writing it without. Okay? So that next page, we are going to be asked to find those numbers. Now, to me, it makes sense if you have your notes open, right? You probably haven't memorized these yet. So look at that list where it said perfect cubes, right? On the other page. Or look at the one on the bottom, right? And fill those in right now. So please do. If I was looking at my answers, let's go with Rowan. What'd you have for the first one? 5. If I'm looking at that next one, what did you have, Aubrey? At 6. The next one, as I'm taking a look at that one, I should have had, is it Abigail? Do you go by Abigail or Abby? Abby. Negative 1. All right, so now we're thinking of this one, and we're keeping it as fractions, right? Just like we did before. If I'm looking at that, keeping it as a fraction, what would you have, Joan? 4 7. Anyone want to change anything else to that we might have? What else? We want negative 4 7. Does it matter if I put the negative out on the top, if I put it out in front of the 4 7s, or I put it with the 7 in the bottom? Would it matter to you guys at all? No, it shouldn't, right? If I put this in my calculator, and I put negative, and then I put 4 divided by 7, or I put it first, or I put it in denominator, all of these are coming out to be a negative decimal, right? Okay. That last one, if I am looking at that one, what did you get for an answer on that one, Sam? 1/3. Okay. So we are going to be taking, so in just a minute, this is what your homework looks like. It's that back page of A1, page A2. When you take a look at that in your workbook, A2, so we kind of mark that page, right? There is only one page of A2 again, okay? So when you take a look, the first one say find the volume. So what am I going to want you to write down? We're going to use V equals, and we are going to put cubit, in this case, centimeters. Now, to me, what makes sense is to probably look back at that list, right? Because you don't have these memorized yet. You're going to be working on it. You might, as the lesson goes on, keep going, oh yeah, 7, I've seen that one. I've done that 2 or 3 times now. Oh, 7 cubed is. Okay, so you're going to start getting those down. Here, you're going to notice you have cube roots, but then you got a square root in here, right? Here you have a square root. So they kind of start mixing them up so you have both cubes and squares as you are looking at those. Okay? Again, keep the fractions as fractions, just like we did. This is what your homework was in.